We're just going to talk about inelastic collisions, and these are just what we've encountered so far. They're collisions where the colliding objects have less kinetic energy after the collision than before. Kinetic energy is not conserved, so all we have conserved is momentum, and we can work out what the kinetic energy is and see how it's changed, but we don't know that it's conserved, and pretty often it isn't. A good example of this, we thought of a bouncing rubber ball in our last example. We think of this this blue ball here being a rubber ball, and so it's really bouncy, so the collision's elastic. Here we're thinking of a stone, which is, I'm not sure if you can think of something that's less bouncy. In other words, if we drop the stone down, say from this height of h, it's moving with this speed of maybe u as it hits the ground. It bounces back up with a speed of v, and it reaches a different height, let's say s at the end. And because this collision is, because this collision is not elastic, it's inelastic, we can immediately say that kinetic energy must be less. And what does that mean? Well, here we have the half mu squared as the kinetic energy, and here we have this half mv squared. Kinetic energy is less, so we need that v is less than u. That is to say that it has less energy, it's moving less quickly when it bounces, if it bounces at all. And the height it reaches, we won't call this s, we'll call it h2, and here it's h1. So we dropped it at this height of h1, and it bounces up to a height of h2, and that's its maximum height, and that's going to be less. And that's what you observe in reality, right? You drop a stone, it doesn't bounce up to where you dropped it from, it bounces up at a pitiful height. And that's a consequence of the collision not being elastic, so it has less kinetic energy. We're going to talk about why the less kinetic energy means it must move to a smaller height later in our video on work and energy and power. But for now, that's just what an inelastic collision means. So we can also work out what the loss of kinetic energy is in the equation. So if we have this collision here, this blue ball and this red ball, they're colliding into each other. We're not going to worry about momentum now. We're just going to work out what the loss of kinetic energy is. We're going to assume that we've worked out what this blue ball is moving at, and this red ball, we've been told, or whatever, it's VA and VB. So we're going to just work out that the original kinetic energy here is a half MAUA squared for the blue ball, plus a half UB squared for the red ball. That's the K before. What's the kinetic energy afterwards? After this collision? Well, that's a half MAVA squared plus a half MBVB squared. The key thing is that these are not the same anymore. And so if we want to work out what the change in kinetic energy is, we have to work out what this is.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.